Atom economy is a method of finding out how much useful product we get out of a reaction. Basically, what we're saying there is that the higher the atom economy is, the less waste is produced. So if I had 100% atom economy, that would mean I produce no waste at all. If I have a very low percentage of atom economy, I'm producing a lot of waste. Now, waste is important because if you're in the chemical industry, you have to deal with waste, especially since we've become more environmentally aware. Waste needs to be disposed of correctly. So it's actually good business to reduce the amount of waste you're producing because it will prevent you needing to dispose it. Okay, which in turn will save costs. So, for example, you've got to take it somewhere. Um, and also it will be more environmentally friendly in theory because if you have a toxic waste product that you could produce from one reaction, but you find an alternative which doesn't produce it, then that waste will never enter the ecosystem because we found an alternative route. So studying atom economy is useful, especially if you have many ways of making the same chemical, to work out which way of producing it is more economically viable and which one is more sustainable in terms of the environment. So, relative mass of the useful product means how much of our product are we actually getting out? How many molecules of our product do we make in the reaction? Relative mass of all reactants is, as it says, you add up all the molecules that you're putting in. And basically, this is a normal percentage. You've got how much out of how much, and multiply it by 100, we get a percentage of atom economy. Here's an example. There are many ways of making ethanol. Here's one. This is hydration of ethene using steam. And this is an example of excellent atom economy because you can see on the left-hand side the steam and the ethene are going to go together to make, on the right-hand side, just one molecule, which means that we don't even need to do the maths here, we can see that 100% of what we're putting in is produced as ethanol, our useful product. But just to crunch the numbers, ethanol has a relative mass of 46, and if we add up ethene as 28 and water as 18 for their relative masses, and we add that together, we also get 46. So we end up with 100% yield. 46 over 46 is 1, multiplied by 100 is 100. Okay, maybe a more useful example would be an alternative method of producing ethanol. Here it is. We can ferment sugar. So I've used glucose for sugar here. Glucose has a relative mass of 180, and the ethanol still has a relative mass of 46, but this time usually we're producing 2 molecules of it, so we're getting twice that. So we're getting overall 92 relative mass units of ethanol for this equation because we've got double the ethanol. But we also have over here waste. We have 2 molecules of carbon dioxide produced. So if we add up the 2 ethanol molecules, we divide that by 180, then we end up with actually only 51.1% as our atom economy. That means that about, nearest makes no difference, 49% of it is waste, and waste as carbon dioxide. So that's going to be vented into the atmosphere, and that's going to contribute to your carbon footprint as a business, and that might have an implication on your tax. There's lots of good reasons why we don't want the carbon dioxide going off as waste. Here's another example, and this is a reaction that you may not have seen before, but this is a hydrolysis of haloalkane. You can see that what we're doing is we're basically taking the bromine off the original molecule, and we're replacing it with an OH alcohol group, and we're getting HBr as a side product. Now, we're only making 1 molecule of ethanol here again, so we're going to end up with 46 for our relative mass of ethanol. But when we add up all of the other things, we've got 18 for the water, but actually bromine's relative mass is 80, and so when we add that on to 24 for 2 carbons and an extra 5, we get 109. So that's actually the reactants are 127 relative mass units, and therefore our sum becomes 46 over 127 times by 100 gives us only 36.2% mass. So when you're considering making ethanol, you would look at this atom economy, and there are other advantages and disadvantages, but one of the considerations is how much waste you're producing, and in this case HBr, not particularly nice stuff, hydrobromic acid, is going to have to be disposed of, and it actually makes up the majority of what you're making. So this would not be a sensible way of making ethanol if you could find an alternative. The hydration of ethene would be much better because you get a pure product.